Aibon Dvepute. Welcome back to my channel again. Today we are going to discuss binomial expressions and expansion of binomial expressions. In particular, the third power, the cube. Let's have a look at how we go today. We are going to connect what we are going to learn today for future lessons. Therefore, make sure that you understand and work through nicely and remember everything. Let's get on with the work. The learning intention for today's lesson is expanding the cube of a binomial expression. Beforehand, what we are going to look at is to have a look at a bit of a revision that we learned so far. We are going to have a look at the expansion of x plus y squared, the second power, or the square expansion, as well as x minus y squared. As you have learned, x plus y squared is simply expanding by writing x plus y times x plus y. And we call this as so-called the FOIL method. First, you multiply two first terms, and then you multiply outside terms, and then you multiply inside terms. Finally, you multiply the last two terms in the brackets. Therefore, it comes as a FOIL method. Let's go through these quick examples here. We have a bit of a revision. Fill in the blanks, and we know that when we expand a plus b squared, it is a squared plus 2ab plus b squared. Well, when you expand the 2x plus y, it's a 2x squared first. Well, what is 2x squared? 2x times 2x, which gives you 4x squared. That's our working. Hence, here we have 4x squared. Then x minus 2y squared, the middle term is twice xy. Here x is x itself, but the y is 2y. Hence this becomes 4, 2 times 2, 4, xy. We write down 4xy. Here we have 2m as our x. We seen that earlier here. 2x squared, that becomes 4m squared, 3n squared. The last term is 3n squared. So let's calculate that. 3n squared. Very important to put brackets because the square governs the number 3 as well. Hence we write 3n times 3n gives me 3 times 3, 9n squared. Therefore, our final term is 9n squared. Well, the next one, our x is 10m, y is 3. We have twice x, y. That's what we write. So the x is 10m, y is 3. 2 times 10, 20 times 3, 60. 60m. Hence we have 60m here. And 3 squared at the end, which is number 9 already written. Okay, let's start expanding this. We'll try to do this a bit quicker. Okay, first one. T squared plus twice the product, 2 times t times 5 plus 5 squared. Therefore, once you simplify each term, we get t squared plus 5 times 2, 10, t plus 25. Then we have 6 minus 5a squared. Therefore, 6 squared minus twice the product. plus 5a squared. Let's write it. 6 squared, 36, twice the product. 2 times 6, 12, times 5, 60. 60a. 5 squared is 25 and a squared. Therefore, we can write 25a squared. Okay, second last one in this expansion. M squared minus twice the product, and then 3n squared. M squared, when you simplify, 3 times 2, 6, mn. Then we have 3n squared. 3 squared is 9, n squared. We go through that. The last one, 5p squared plus twice the product, 5p and 6q. Then 6q squared. 5p squared, 5 squared is 25, p squared, twice the product, 2 times 5, 10, times 6, 60, pq, then 6q squared, 6 squared is 36, q squared. Righty, we go through that. Let's have a look at how to evaluate these squares using binomial expression expansions. First one is 42 squared. We can write down 42 as 40 plus 2 squared. Then we apply the formula. So we get 40 squared plus twice the product plus 2 squared. So here we get 1600. Here we get 2 times 4 times 2, 8 times 2, 16. Therefore 160 plus 4. So the answer is 1764. The next one is 203 squared. So 203 can be written as 200 plus 3 squared. 200 squared plus twice the product plus 3 squared. Now 200 is squared. 2 times 2 is 4. So you get 40,000 plus 2 times 2, 4 times 3, 12. 1200 plus 9. So the answer becomes 41,209. The last one here in this set, 99. The 99 can be written as 100 minus 1. Well, we use the x minus y squared expansion here. 100 squared minus twice the product plus 1 squared. Here you get 10,000 minus 200 plus 1. That's 9,800 or 9,800 plus 1. 9,801. Okay, so we've done that. Now we are going to look at the cube of a binomial expression. We can write this as x plus y times x plus y squared, where we know x plus y squared. We have done this before. Now we are going to expand this using x plus y. So we are going to multiply every term in this purple bracket with the terms from this orange bracket here. Therefore, we get x goes on to that, and that. So we get 3 terms. Let me write that in blue. X times x squared, x cube. X times 2xy. 2, there are 2 x's multiplying each other. 2x squared y. X times y squared, x y squared. And then we have y goes on to each of these. Let me write them in red. Y times x squared, yx squared. Y times 2xy, it's 2x y squared. Y times y squared, y cube. Now we are going to collect the like terms. Let's see what are like, what are not. So x cube by itself, if you look at here, this term 2x squared y, and also yx squared, it's x squared y, so they like terms. Hence we can write down, there are 2 here, 1 there, 3x squared y. And then we are going to look at the next like term, xy squared, it's plus, as well as 2 of them, xy squared. Therefore we can write altogether 3 xy squared, and at the end we have y cube. Well, that's our cube of a binomial expression. We expand it, and that's our answer. Let us do the x minus y cube in the same manner. Now you get the hang of this one. We can easily write down this as 2 products, where we can write, let me get a different color, x minus y squared using our square expansion. Now we are going to distribute x onto each, as well as y onto each. Let me get a different color for that. Okay, so let's write the orange ones first. X times x squared, x cube, x times 2xy is 2x squared y, but negative. X times y squared plus xy squared. Then let's distribute negative y onto each of these purple terms. Y times x squared, yx squared, but negative, because you have a negative sign here and a positive here. Multiply those two gives you negative. Negative y times negative 2xy, that becomes plus, positive. Y times y squared, hence we would have 2xy squared. Negative y times y squared, y times y squared, y cube, but negative. Now let's pull the like terms. X cube, it's only 1 here. And then if I look at x squared y and x squared y, or yx squared, they're the same, but negative 1 here, negative 2 there. Therefore we would have altogether 3 of them, but negative, x squared y, as well as we would have here xy squared, 2 of them. Now in this case it's positive, and then finally we have y cube. So we go through that too, and we can have a look at this one in a different way. We remember the expression 4x plus y cube, and we can use that one to find x minus y cube as well. So what we're going to do is we are going to simply rewrite x minus y as x plus negative y. Then we apply the cubic expansion for x plus y. Now let's write. We would have x cube plus 3x squared y, here in this case negative y, plus 3xy squared, where y is now negative y, and finally plus y cube, which is negative y cube. If you expand this one nicely, these brackets, negative times positive becomes negative, hence we would end up with x cube minus 3x squared y. Negative y square becomes positive, therefore this stays positive. Negative y cube multiplying negative y by itself 3 times yield negative y cube. Therefore we got exactly same expression we got earlier, just in there, exactly the same. So these are those two. Now we are moving into examples. So we're going to have a look at some expansions of binomial expressions, and I have given you different forms that you can encounter in examinations. If you work these through, you will be fine. First one, a plus 2 cube. So we would have a cube 3a squared times 2, because that's your y, plus 3a times 2 squared, y squared, plus y cube, in this case 2 cube. Now let's simplify. A cube, 2 times 3 is 6, 2 squared is 4, times 3 12, a 2 cube is 8, 2 times 2 times 2. Next one, 1 plus b cube, 1 cube plus 3 times 1 squared times b, 3 times 1 times b squared plus b cube. 1 plus 3b, we can see any power of 1 is 1, hence we can easily write this b cube. Also notice the power of b is increasing here, b to the power 1, b to the power 2, b to the power 3, and we can discuss this one in Pascal triangle as well later. There's a nice connection between these powers of x and a y. Let's move on to the next one, w minus 3 cube, where we get different coefficients now, just other than 3's and 1's. W cube minus, this looks like x minus y, therefore we use that expansion. 3w squared times 3, that's your y, plus 3w times 3 squared minus 3 cube. Remember, this one is just 3 cube, not that. That's different. That's not this. This is just taking the cube of 3 and putting a negative in the front. Okay, let's write w cube, 3 times 3, 9. Now you can see the coefficients are changing to different numbers depending on the y value or the x value. We will see a bit more different ones later too. Here plus 3 squared is 9 times 3, 27. And 3 cube is 3 times 3 times 3 is 27 as well. Okay, let me do that. Okay, nice w here. Okay, 4 minus p. Now in this case, the x is a number, y is a variable, or rather we call this as a pronumeral. 4 cube minus, again x minus y form, 3 times 4 squared y, in this case p, plus 3 times 4 times p squared. You can even put times here, or you don't need to. Minus p cube at the end. Now we have 4 cube. 4 times 4, 16 times 4, 64 minus 4 squared is 16 times 3, 48 p plus 4 times 3, 12 p squared minus p cubed. Okay, we're going well. Okay. Next couple. Negative 5 plus k cube. This can be written as k minus 5 cube n expanded. Well, let's expand as this. In this case, x plus y form. So negative 5 cube plus 3 times negative 5 squared y, which is k, plus 3 times negative 5 times k squared plus k cube. Okay, let's simplify. Negative 5 multiplied by itself 3 times, so we have negative 5 times negative 5 times negative 5. Negative 5 times negative 5, 25, which is positive, and then again a negative becomes a negative 125. You have to multiply by 5. Here we have negative 5 squared, which is positive 25 times 3, 75k, but positive. Here negative 3 times negative 5 times 3, negative 15, and k squared. Finally, we would have k cube. The next one is negative cube, negative 6. Well, we can do this one in 2 different ways. Let's split negative cube, negative 6 as negative cube plus negative 6, and then apply the formula x plus y cube. Right, we get negative cube as we did before. You can see our y is negative 6, and I am putting brackets to differentiate those negatives nicely, and you better do that too, making sure that you get the right answer. Negative 6 cube. Now we are going to look at the answer. Negative cube, when it is cubed, the answer becomes negative, then negative cube. Negative q squared is positive q squared, but negative 6 times 3, negative 18 q squared, and here we have negative 6 squared is 36. 36 times 3 is 108, but negative with that, so 108 q. Negative 6 cube, you multiply negative 6 by itself 3 times. Negative 6 times negative 6, positive 36, and times by negative 6. Let's forget the negative for the time being. 36 times 6, 216, but negative now. Okay, that's your final answer. Another way that we can look at this would be simply pulling negative 1 out of these two values. So factorizing with negative, and applying 3, the power 3, into each term inside the bracket. Now first write down q plus 6 here because you pulled out the negatives. Then you apply the power 3 using index lows, and q plus 6 also governs by 3, power 3. Now negative 1 to the power 3, negative 1 times negative 1 times negative 1 is negative 1. Okay, let me put a big bracket and then write down the expression here. Okay, that one, q plus 6 to the cube, so we get q cube plus 3 times q squared times 6 plus 3 times q times 6 squared plus 6 cube. Now if you write down the answer, negative 1 times q cube plus 3 times 6, 18, q squared plus 6 squared is 36 times 308 q, and then 6 cube is 216. And if you look at the previous solution that we got here, for that is exactly same as the one that we got here. I have simply pulled the negative 1 out of the terms here. So simply factorizing that with negative gives you that exactly the same answer. You can either leave that or this one as your answer. Okay, let's move on to a worded set once we evaluated these values using the cube of binomial expressions. Okay, now we are going to look at, that's your full example question. Read it. Okay, once you read, let's move on. 31 cube. 31 can be written as 30 plus 1 cube. Now what we are going to look at is expansion. 30 cube plus 3 times 30 squared times 1 plus 3 times 30 times 1 squared plus 1 cube. Okay, let's simplify. 3 cube is 27, and with 3 zeros we get 27,000 because 10 to the power 3 gives you 1,000. 30 squared is 900 times 3, 2700 or 2700. 30 times 390 times 1 doesn't change it, plus 1. Okay, we get the answer for that one as 29,791. Right, 48. 48 can be written as 50 minus 2 then cube. Now we are applying the x minus y cube. So 50 cube minus 3 times 50 squared times 2 plus 3 times 50 times 2 squared minus 2 cube. Again here taking the cube of the 2 and setting a negative in the front, which becomes negative 8. And I have written that one first. Now let's write everything from the beginning. 50 cube, 5 cube is 125, 10 cube is 1000, so 125,000. Then we have 5 squared is 25, 25 times 2 is 50, 50 times 3 is 150, then we ended up with 15,000 for that. And then we have 2 squared is 4, 4 times 5 is 20, times 3 is 60, so we have 600 here, minus 8. I'll write that one bit closer. Now if I evaluate everything here, 125,000 minus 15,000 plus 600 minus 8, 110,592. Okay, we go through that. Let's have a look at this question. Find the volume of a cube with each side 5p minus 2. Now in terms of p, of course, let me draw a cube first. You can easily draw that. It's a rough sketch. What we've been given is length, width and height. They're all 5p minus 2 centimeters. So we get an expression for volume. If the side was simply x, the volume is x cube. Now in this case, length is 5p minus 2. Now we are going to expand that. Let me write the answer here. 5p cube minus 3 times 5p squared times 2, that's your y, plus 3 times x, which is 5p, as in the expression, and then you have 2 squared minus 2 cube. Now if I expanded these brackets nicely, 5 cube is 125, and then p cube, 5 squared is 25 times 375 times 250, p squared, 2 squared is 4, 4 times 5, 20 times 3, 60, 60p minus 8. Well, that's our volume of this cube, with each side being 5p minus 2, and the answer is in cubic centimeters. Okay, one last one. We are going to write the expression here as a cube, and then we write the answer. Well, if I look at that, that's in fact x minus y cube. Well, if you cross check with each of these terms, x cube, 51 cube, and then the last one is negative 49 cube here negative y cube. Therefore, x becomes 51 and y becomes 49. Therefore, this expression is simply 51 minus 49 cube here. Well, what is 51 minus 49? Easy one, isn't it? 2 and then cube. 2 cube is 8. The answer is legendary number 8. Well, that big expression now is in fact simplified down to just 8. Okay, Due Pute, I think we learned a lot today. We discussed binomial expansions and third power expansion in particular, and we solved some problems, even worded problems. I hope you gain a good knowledge. Please retain that one. We will be using that one very soon in our next video lesson. Until then, I would say Aibowan, Teruan Saranai.